recording, and we'll join back up on the voice channel over here. Hello. All right, we're back. We're back to talk about some more fun stuff. Specifically, things like Singletons, Structs, Invoke, and libraries. I think I hopefully pressed all the buttons I need to press. All right, I'll give people a second to join in. And this is going to be relatively brief in comparison to the earlier one. But we'll go into cover sort of a bunch of important things that will make life easier, certainly in general, and on the project, the Apple Picker project. All right, let's hope I got that. Okay, seems like things are working. Scene, there we go. Okay, this is the Miscellany. The Miscellany lecture. What Miscellany is. Miscellany, a group or collection of different items. Miscellaneous, it is a mixture. So this is sort of the mixed bag portion of the lecture. It kind of knits together some of the things that we saw, give you a couple of things that will bridge us to some other techniques, and just kind of fill in the gaps. Things that I don't think quite really warrant a whole lecture in and of themselves in each one, but worth covering and going over, and you may very well want to refer to them in the future, use them in your projects. Okay, so Singletons, Structs, Invoke, libraries, mathf, and random. So want to take a moment, and maybe normally I would have done Project 1 retrospective. I did that earlier before. So what did you learn? Think about things. What did you learn from Project 1? It was supposed to be sort of a brute force way. So you get appreciation for, sort of a lot of the things that Unity does more or less automatically for you. And now as we see other things, as we move beyond what you wish you had learned instead or learned differently, always, if there's anything that you just thought was really, really weird and bizarre about that project, let me know. I appreciate it. I think people put a lot of thought into it, a lot of work in, more so than than I had. That usually, it's always fun to see how people kind of approach that project, because it kind of pushes people outside their comfort zone. It's not the typical game. So, did you use update? Quite a few people did. And like I mentioned in the last one, it's normally, did you really need to use update? I don't know. Update is more like a polling thing. Update happens over and over again. It happens once per frame. And the last game was really more a turn-based game, right? So how often did the user interact with the game? Really just, once every mouse click. So the interaction between user and the game was on the order of every few seconds. And if you think about it, if you're using update's happening hundreds of times, or maybe hundreds of times depending on your machine, dozens if not, lots and lots of times per second. And the question is, do you really need to keep checking things over and over again? Did something change? Did the user move? And so on. And in this sort of game, really didn't, it wasn't like performance bound or anything like that. But there will come a time, potentially, certainly in writing video games or writing any type of software, where performance becomes an issue. In my experience, I wrote a lot of software that is doing video compression and decompression. So therefore, as you get into, even standard def, once upon a time, the number of cycles spent per pixel on anything was critical, right? So we're always looking for places to streamline things. So often in software design, especially in games and things that are sort of out to be real time, you do want to consider, how often are you calling functions? Do you need to call them as often as you do? Does it make sense to do something just every time the user clicks the mouse or clicks a button, as opposed to doing something on every frame update potentially? Very, very different. Something to consider. All right, Project 2. Again, do before you know it. So start now if you haven't already. The apple picker do want you to think about also uh, polishing the edges on your start screens and so on. Get all that underway. Think of it as Kaboom with apples, also known as you score points by catching stuff dropped by a randomly moving antagonist before they hit the ground. Not the antagonist, but the things that are dropped, right? So you can use this for anything. Could be something that drops something, you have to catch it. Simple enough. Main key values, key important things are that there is a number of baskets or fire trucks or trampolines or whatever it is um, on the bottom of the screen that all move as a group, and the number of them indicates how many lives you have, um, and that's important, right? So there also is the important thing that if one hits the ground, one of the dropped items hits the ground, all of the ones that are currently in play disappear, right? So it makes it sense to manage them as a list. So that you can easily maintain, figure out which ones to destroy and so on. And then it makes sense to potentially keep track of the baskets or whatever your catcher things are as an array because they are finite, right? So things in general about this project and other projects. As you approach the projects in this class, please, if you want to get fancy, consider this, right? Please develop progressively. Some people like to just like throw everything all at once and hope it works. And sometimes that'll work. If you're newer to programming, that's sort of potentially problematic because you have to debug sort of everything at once, and that can be challenging. So you want to develop potentially progressively. And games should also play progressively, right? Don't start out as insta-kill. So even the simple apple tree program here, you want to drop, things should move at a certain pace and then progress as they move on, right? Play should be learnable in games, especially if there is something like insta-death. You don't want it to be random every time when the fate is instant death. That's going to be a frustrating game. So if there is an instant death game, you should be able to sort of remember and learn through here. So think about that as in your future projects. Go ahead and use scenes as levels and structure overall. We're stressing that a little bit more now with our start screen and choosing levels and choosing what game to play and so on. These are generally designed to be, fairly straightforward. Don't get too complex, especially if it's. I need to be able to judge your game and look through things and look through your code in a finite amount of time. 15 minutes, half an hour, to kind of really get through things. Makes sense if I'm not looking for epic sagas. So it's nice to be able to demonstrate everything up front so I can see it and then potentially see the rest of the game and experience as much of it as I can. That's great. But be careful about getting too complex. Now, all these things are especially important since we're going to be bundling our games into one project for purposes of this class. So be aware of these. All right. I want to talk about a few general and important concepts. A few of them come from C# programming practices. Some of them are really just useful Unity scripting features, and some are from this class of software patterns. One of them in particular. You may have heard of the thing called Singletons. Anyone familiar with Singletons? Anyone out there? So there's this great book, which I have a copy of somewhere here. Let me find the reference on here. Okay, good. There's a great book by Robert Nystrom, and I actually just ran across a YouTube video by him as well. And he goes through specifically game programming patterns and likes to talk about ones that he finds useful and not useful, and talks about singletons particularly as something he likes and doesn't like and sort of interesting. So if you are interested in picking up a copy of Game Programming Patterns or getting a virtual copy of it, it's a really great book worth talking about. And the singleton pattern is one of the patterns that is really, really useful in Unity for as sort of a piece of a puzzle, a particular piece of a particular puzzle, which is this notion of don't destroy on load. There's a feature where basically when a scene loads, normally what happens when a scene loads is that everything in the existing scene gets torn down and destroyed, and then the new scene comes into existence, right? So it tears down everything in one scene and then loads the next scene, loads all the game objects, components, scripts, etc., etc. But there's a feature called Don't Destroy on Load, in which a particular object that has been set as Don't Destroy on Load, it is not torn down, and it survives into the next scene. And that in and of itself is a cool thing, but it requires careful management, especially if you can then leave that scene and go back to the original scene where it was first created. So you can imagine a loading screen that has music that plays. So the start of your game has music that starts to play, and you go into your game. You use Don't Destroy on Load because you want the game music to continue to play. If you want that to happen, you don't want the music to stop and start again. So you use Don't Destroy on Load, and then you go back and you go into your scene and so on. The game ends. The music is still playing. You return to the menu screen, and the menu screen says, okay, let me start the music again. Right? Because the Don't Destroy on Load survived that object. Once you call it once, it persists, right? And then what will happen is that original scene will build another object, potentially, which has another audio source on that has the background music, and so on and so on. So you can get into the situation where you create multiples of a particular object because you use Don't Destroy on Load. So particularly for that object, we like to use singletons. And what a singleton does is basically it's a way to ensure that only a single instance of that class or that object will exist. Right? So normally what we do is we say, okay, there's got to be some kind of unique identifier as this class comes into existence, as this instance comes into existence, that will say, okay, do not allow any others. If I then try to create another version of it, don't let that happen, right? Only let one of them. The singleton, it is a single instance. It enforces this singular nature of that. Okay, so what I have here in this frame is one version. I mean, there are lots of different subtle versions of this. This is one that works pretty well, and it kind of runs. It checks all the boxes, in terms of making sure that the singleton works. Now, the way that the singleton works is also, there is something that I touched on in my example of using the static, using classes as having some portions of the class, some functions that are a singular, that are shared across all instances. That's the notion of static. If you have a method or a variable or a property that is declared as being static, it is something that is shared across all instances of that class, right? So we can use that, we can exploit that static to check to see, okay, is this the only one? Is this already claimed, right? It's like musical chairs. Think of it as musical chairs. Has everyone played musical chairs? Do I need to explain what that is? So the notion of musical chairs, of course, is that there's some number of chairs and people wander around the chairs, and you all try to sit in the chair, and of course only the first person who sits in the chair gets to sit in that chair, and anyone else loses the game. Imagine you're playing musical chairs and you only have one chair, and someone joins the game, and only one person gets to sit in the chair. That's the same sort of thing that can happen with a singleton, with this particular construct here, right? And what we do is we have this instance variable, this instance property here, which is a hidden chair, basically, that everyone's going to try to sit in, right? It's named the same as this, so it's going to be, a instance pointing at this, which is kind of fun in that it's going to point to itself, potentially. It's going to try to sit in its own chair. The first one that gets to sit in the chair here, private static singleton underscore instance. This is the internal hidden instance. It's the chair that they're all going to try to sit in. Okay. Now, there's public static, meaning anything could potentially call this. We use a getter to get the instance, right? So anything can say, okay, give me the instance that is actually in play here, right? Rather than try to get we don't want anyone really touching this other than the class here itself. But if something else needed to refer to it, you can use a getter, right? So this get function, if anyone says singleton.instance, it's going to return this, but it's not going to let you see the real one. It's going to let you see it, but anyway, hides it, but allows you to access it. And then the important thing that happens is during awake, which is the first thing, it's sort of like start, but it's earlier. Awake happens before start in the creation of a mono behavior, an object. It happens before, all of the other good stuff. It's the earliest case, and we'll talk more about awake and update and start and like all those functions and how they work as we get into when code runs. We don't really need to understand all of that right now. Just know that there is this awake event or this awake method that happens before start. It's one of the earliest things that happens inside a class, inside an object that is instantiated. And right in there, we want basically to try to sit in the chair, right? I'm going to really just kill beat that musical chairs reference to death. I don't know, hopefully it makes sense. So the first thing it does, it says, okay, if underscore instance is not equal null, this basically means if no one is sitting in the chair, well, sorry, other way around. It says, if someone is sitting in the chair, I should say, if it's not equal null, right? So if someone's sitting in the chair and it's not me, so it actually checks. It says, okay, if someone's sitting in the chair, the instance already exists, and for some reason that instance is me, it's because you could do something. There can be weird situations where the object goes into another scene and it awakens again. There's in being in another scene, this awake could happen again. So it wants to make sure, okay, instance is already set and it's not me. If that happens, then you go ahead, delete the extra ones. You came into this somehow and you shouldn't have. You did not sit in the chair. You're not the person sitting in the chair, and the chair is already full. If that's the case, you destroy yourself. You destroy not just yourself, but the game object that you are a component of. Right? It goes ahead and destroys that. Otherwise, if that didn't happen, that means, okay, nobody's in the chair and it's not me. Okay, good. All right, I can set it to me. I can sit in the chair. Set the instance to the current object. And finally, set don't destroy on load for this game object that you're on. So this is a very useful one. Now, I use it a lot in my, like I said, having game music that plays and continues from scene to scene. That's a useful thing for it. Also, potentially, if you had a canvas that you wanted to have that went across scenes, or any particular type of object that you wanted to have exist in multiple scenes, and you didn't want to accidentally create multiple versions of it. If you knew that you were never going to return to the originating scene, perhaps you wouldn't need this. But if there's a chance that you might return to the scene and accidentally create another one, this is a good way to use the singleton pattern and don't destroy unload together to do something useful. So we won't go into all the other software patterns and the other game programming patterns, but this is a good one to sort of, as they say, whet your appetite with. And I'll leave the other ones for you to look up and check out. All right. So another thing worth mentioning, I mentioned this a little bit in some of my other lesson videos, structs. So those of you who are familiar with C and older languages as well, you might be wondering, well, what happened to structs? We didn't talk about structs. We talk a lot about classes, but we don't talk a lot about structs necessarily. Structs are certainly useful things. Structs are sort of the little sister of classes. And typically you're going to use them kind of as if you have a class, you have some kind of small object that you want to quickly spin up on the stack. Right, so say you have, for some reason I want to quickly, have a couple of different enemies or some structure where, it's something that I have, some kind of, quick thing like, zombies. They don't really have any behaviors of their own. You just need to use them kind of quickly. most of the functionality of the class is actually there, but there is this specific, you'll notice I said quickly spin up on the stack, right? They are, unlike classes, they are usually used by value, right? So we pass them around. They're sort of, they generally exist in local address space, in local space, as opposed to being a more global referenced structure, something that exists at a higher level within the C# namespace and so on. So they're generally small objects that are passed by value as opposed to pointers to them as references, right? So they're useful for these sort of small things, like say you just wanted to keep track of, create some kind of structure that was, creating a map of obstacles in a room that you want to use in your program, or here's like, yeah, here's what it is. Imagine an obstacle that's at a certain position and has a type, right? And we can initialize this obstacle at a position having a type, and then we can kind of create them. So you see they're very similar to, in certain ways, very similar to classes, but they are generally considered to be more useful for kind of lightweight, simple things. So if you need to, that's what structs are for. Right. This one's a bit of a reminder, and also to introduce you to a couple of other little things about navigating a scene. Now, people, for the most part, I think did a really good job of this in terms of finding, working through the scene hierarchy and object hierarchy. One of the first things you discover is, of course, using game object, capital game object, that is, dot find. So using the a static method across all game objects, something that's across all the game objects there. Use the find function to go through and look for a game object by name, right? And that's a nice thing to do in your scripts instead of using public game objects and kind of dragging and dropping them in the Unity editor. There were a couple of problems in some of the projects where there were some uninitialized game object references. This is a great way to avoid that, right? If you explicitly look for a game object, then that frees you up from potential problems with like forgetting to save something kind of in the editor that you then used in a script, right? So if you want your scripts to stand alone a little bit better, you can use gameObject.find instead of using the public game objects that you need to then fill in pointing, clicking, dragging, and so on. Okay. You're probably at this point pretty familiar with gameObject.getComponent and getting a component of a certain type, right? So if you needed to get an audio source, or you needed to get a rigid body, or you needed to get any sort of collider, this is probably the most commonly used get components way of finding a component on a game object. All right, we see that used a lot. Get component, that type. Now, if a game object has multiple components of the same type, like perhaps they might have multiple audio sources, or they might have multiple colliders, or they might have some number of different components that are of similar type, you can use get components with an S, and that's going to return an array of components, one or more components that belong to that. All right, so that's yet another variation. And another slight, another member of that family, get component in children. Right. This is useful, like, for example, when we wanted to change the text of the toggle component, right? The toggle, sorry, not the toggle component, the toggle object. The toggle object itself on the canvas doesn't actually have text in it. It doesn't have a text component. It's a sub-object of that. So the toggle is an interesting object in that it has a hierarchy. And the text component, you have to use get component in children so that it traverses down the tree, down that hierarchy, to find components of children objects. And that's becomes an important thing. Like if you're trying to do work at a higher level in a hierarchy, but you need access to there's like one particular thing, like maybe it's the sprite renderer, right? Maybe the sprite renderer isn't at the root of the game object that you're working with. Maybe it's at some, further down in the tree, the hierarchy. So that's something to refer to. Now, if you want to get really advanced and fancy, and you don't want to refer to things this way, and you don't particularly, maybe you want to, um, you're not sure if the component exists on that object, right? You might see, like in each of these, technically you should check to see if these succeeded, right? There is a version or a family member here called try get component. In this version, if you say gameObject.try get component, you can actually tell it, okay, try to find an audio source component, and if it gets it, if it can find one, it will return it as filled into my sound. For example, audio source my sound. Let's use this out specifier here. It's out decoration here. So a more advanced option when you're not sure if the object has that component, you can actually try to see if it had one of those components. Another topic. So on the last one, this use of mathf and random, certain libraries, and even vector3, vector2. A lot of the time, we're referring to these sort of what seem like classes. They are basically static classes that you can invoke without instantiating, right? Libraries. So mathf.abs is a method of this mathf class, which effectively becomes a library. Right? If we declare this method to be static and public, then it becomes something that we can refer to. Right? There's nothing unique to a particular instance, and we never put the math library, we never put a math class, a math component on an object. Instead, we just refer to it by the name of the library. Right? So here, for example, we had our clamp that we used all over the place, where we said mathf.clamp. There's also things like mathf.abs for absolute value, and so on and so on. So those are libraries that we can use that way. And similarly, we also encountered the random library. And you can create your own libraries, right? So you can do this as an exercise. If you have something, some sort of mathematical operation, or some sort of, maybe it's some pathfinding, or some planning, some AI, something like that you want to implement as a general resource, but you don't need to instantiate a particular version, you can use this technique to create, sort of libraries that you can use across your project. Now, this one. This is I always view this invoke as sort of a stepping stone to coroutines, which is something we really want to use. Invoke is we refer to invoking. It's another way of referring to calling a function. If you invoke a function, you're calling a function. Now, there are some functions that allow us to sort of schedule when schedule when a function is going to be invoked, right? So normally we would say, oh, we want to have something happen at a certain interval, a certain rate, and so on. We'd probably go and reach for update to do that. We'd say, oh, okay, maybe I compare to some get time or something to figure out, okay, should something happen at a certain time? But there's this convenient set of functions called invoke that allow you to do things based on either a delay or at an interval. So it's an alternative to doing things inside your update function if you know the interval that you want them to happen on. Don't recommend doing this at a very high interval rate, very high frame rate. It's more in the order of something you want to do every few seconds, right? So the normal version or the base version of invoke, you say invoke, give it a function name, and you give it an optional delay to say, okay, call, which basically means call this function once after some delay. Right? That's the base form of invoke. And then we have invoke repeating, which allows you, basically do the same thing. Invoke a function after a certain delay, but then keep calling it repeatedly after the delay and then at that interval. Right? So if you wanted to call a function every second or every 5 seconds, you could say invoke repeating and then tell it at what interval, after what delay and what interval to call it. Cancel invoke allows you to stop pending invocations of either a function or all pending. And like I mentioned, this is sort of a stepping stone. The bigger sibling to this is coroutines, and they're much more powerful in terms of what they can do. But Invoke is a good stepping stone, so I like people to try things out with it. So let's do a quick example of Invoke here. All right, so we're going to go back to our Lego tree guy up here, and we'll go ahead and we'll put him on the screen. And you might remember I stopped here and I said, this is kind of weird. This change direction at some, not really at an interval, but according to some random chance. This was problematic. Why? Because, well, we got into how often is it being called, at what interval is it being called, is it at the frame rate, do I multiply? It gets tricky, right? So instead, I'm going to use this as an opportunity to demonstrate our invoke, our use of invoke potentially. Right? So leave that out for a moment, and I'll say, all right, I'm going to have a function that says, that's just called change direction. Void change direction. And what change direction does is it just says speed times equals -1. All it knows how to do is change direction. Right? Now, what I could do then, say I want to change direction every 2 seconds. I'll come up here in my start and I will say invoke. And, well, for starters, I could say invoke change direction and have it happen after 2 seconds. So that's my base version of invoke. So 2 seconds after this starts, it will change direction. So no matter where it is, and I didn't quite catch that. I don't know. Oh, see it changed direction there? Now it didn't change direction there. All right, so let's play that again. So it bounces off and it changes direction right here. 1, 2. Right? So I kind of scheduled 2 seconds in the future, change direction. And that went away. It didn't, it's not doing it again. Right? So this use of invoke here just said, okay, 2 seconds in the future, call this change direction routine. Now, perhaps instead of that, I want to have it do that every 2 seconds. So I would use invoke repeating to do that. I'd say, invoke every 2 seconds. So wait 2 seconds and then invoke it every 2 seconds. So I'll start it and you'll see there, 2 seconds, 2 seconds, and again 2 seconds, right? So it looks kind of random here, but it's not really. It has, if it hit this edge, it would change direction, but then also at a 2 second interval. So now it's sort of settled into a rhythm here, right? It takes 2 seconds to move from here, hit this edge, to get to here, and vice versa. So it always moves back and does something fairly repeatable there, right? So I could have even set up something where I said, well, okay, if I know I started at 0 and it takes this long to move, I could have had him changing direction according to that if I wanted to. That's one way of doing it. But now, let's say we'll leave it at that. All right, let's jump back to our notes for a second and see. It's going to take this in a little bit of a further direction. And I'm going to ask, how many of you are you? I'm assuming that most of you are familiar with recursion. So please go ahead and tell me that you are. Yes, unfortunately. Okay, recursion can be your friend. Recursion sort of gets a bit of a bad rap, I think, but recursion is a very, very powerful tool. Now, we'll loosely call this recursion. Okay, So it's recursion. Basically, it's a function calling itself, right? So a function calls a function because it's the same function. So for different types of things like factorials and things like that, it makes sense to be able to do that sort of thing. And things that you want to have repeated potentially, we can we can invoke a function recursively. So imagine you have a function and it calls itself, but it calls itself in such a way that doesn't just call itself immediately. It can call itself after a certain delay. Right? So this is another way to basically use invoke repeating, except we could control the rate at which it invokes itself, the rate at which it recurses. So sometimes you don't want to call functions at a set interval, or you're not sure you want to run that function again. Perhaps you might want to just stop after the fifth time or something like that, after 5 seconds or something like that. So we can use invoke. We're going to invoke the function name delay recursively. So imagine here we start, in our start, we say invoke change direction randomly, and we say, okay, call that randomly between 1 and 3 seconds from now, right? So we'll wait between 1 and 3 seconds from now to call change direction randomly. And then inside of our change direction randomly, it knows how to call itself recursively, right? So it invokes itself again with that same random dot range 1f to 3f. So it calls itself, it says it schedules itself again to occur 1 to 3 seconds from now. Okay, so let's I can even grab that and I'll double check my, whoops, and I should fix this if I run into problems, right? That'd be good. So now let's come down here and we'll leave our invoke change direction randomly. Take that one. And let's see, oops, this should be, put this up here, and we will not invoke change direction, but we will invoke change direction randomly. Why is it upset with me here? I somehow cut and paste something odd here.
You're missing an ending parentheses.
Yeah, I'm trying to figure, where did I, oh, just right in
Invoke.
Here we go, yep. And probably missed it up here too. Yeah. There we go. Ah. Right? Invoke. Right, I'm still missing something. Oh, you know what? It also was a kind of a weird, not just the parentheses, but my quotation marks. Those were real open-close quotations as opposed to just double quote. So we had two bugs, one bug hiding another bug. So now we have change direction randomly, but thank you for that. Yep. So I have to make sure that my parentheses are balanced and that I'm using the proper quotation style here. All right, so now we can do this, and now our movement should appear wonderfully random. Except for one thing. This is that we didn't actually put the code in here to do this. I'm going to do this. I'm going to say, well, not quite sure why I'd want to do it this way. It's a little obtuse. But yeah, of course, inside change direction randomly, I should take the time to change the direction. I'm sure you'll notice that. We're about to. You're too polite to tell me to do that. So now our enemy, sure enough, is bouncing around wonderfully, changing direction randomly. It made it all the way to the side that time. So if we wanted to then extend that, we could certainly, these numbers are, right now we know that it's changing direction every 1 to 3 seconds, right? If you wanted to change it more often, you would basically modify these two parameters. You could have an upper and lower limit, right? So as the game becomes more complex, you might want to have it change direction more often, right? So you can always modify those values to scale. As I mentioned in the lecture notes, here's an opportunity for us to go back and say, okay, play progressively. So shrink those intervals, increase those speeds as the game plays. All right. So let's see. Here we were. We had our invoke change randomly. And that's it for the afternoon. That took us way past our time. But I wanted to cover those things. Each and of themselves are, I think, very, very useful. And fill those in. Try those in. Each one of those should be something you could try, as its own sort of little exercise to try. Using a singleton with some sort of object that you want to have persist across scenes, whether that's background music or some sort of canvas element, or it could be as simple as a watermark or logo that you use. If you want your name to appear in the upper left corner, upper right corner of every screen of your game, perhaps that's what you do. Right. So exercise a singleton pattern. We'll be looking for that as a demonstrated technique. If you are in need, you can certainly use structs and so on. Try creating your own library of some useful thing. If you really even want to just use, create your own clamp functions or your own, well, I'll let you come up with a good circumstance to do that. All right, that's good enough for the afternoon. Thank you very much for tuning back in, and give those things a try. Again, hopefully everyone's checked out your grades. If you have any questions, let me know. And I will see you all again. Probably post a couple of bit more lessons or things to try during the week. And then I'll see you all again on Thursday. Have a great week. Take care.